Hello everyone. Very good afternoon and welcome back to my channel. So today we'll be doing chapter 11.3 of NCERT Class 8 Mathematics, that is related to solid shapes. So we'll be dealing with the concept of solid shapes, how to derive the formula for your calculating the total surface area, curved surface area, and what is the difference between total surface area and curved surface area. And after that we will begin solving the questions of chapter 11.3. There are 10 questions. We will be solving all of the 10. So before moving forward, what is the solid shape? First understand what is a solid shape. So a solid shape is something object that is having length, width and height, and that takes some space when you keep it. So unlike two-dimensional, it is a three-dimensional figure. You can see length, this is the length part, this is the breadth, this is the height. So if you place this, or you consider if you place a matchstick, it will occupy some space in your room. So solid shapes are something that occupies the space. So in this chapter we will be dealing with cuboid, cylinder and cube. Other solid shapes are cone and pyramid. So from the scope of this chapter we will be covering these three. Surface area of a cube, cuboid and cylinder. The surface area of a solid is the sum of the areas of its faces. So when you see, if you meaning of surface area is area of this part, area of this part, area of this part, this part means area of all its faces. In cuboid you have 6 faces, so area of all the 6 faces. In cube you have also 6 faces, so area of all the 6 faces. In cylinder, area of this part plus this part plus this part. So this is the actual meaning of surface area. Now first we will see cuboid. So best example of cuboid is a matchstick box. So when you open an empty box, it will be like this only. This is the, you flip it up, this will comes like this, and if you open from each of the joint, it will open like this. So if you number the rectangular shapes, so number this one first, second, third, fourth, fifth and sixth. So this is the height, this is the length and this is the breadth. So you open again, this height will be common for all. This is the length, this is the breadth, this is the length, this is the breadth, and for the upper part which you have opened, so this is the breadth and this is the length. So when you calculate the surface area, total surface area, you have to calculate this and this. So area of all the 6, and all our 6 represents, it resembles the rectangle. So you have to calculate the area of this rectangle, all rectangles. So total surface area of cuboid is area 1, area 2, 3, 4, 5, 6. So you see h into l, area 1, h into l, area 2, b into l, area 3, h into b, h into b, area 4 again h into l or l into h, sorry, area 5 b into h, and area 6 l into b. So if you sum up, so this is h into l, this is l into h, this is 2, b into l, b into l, b into l, this is also 2, b into h, b into h, this is also 2. So total surface area is 2 into hl into bh into lb. If you arrange 2, total surface area will be 2 into lb plus bh plus lh. This is just for easy remembrance. So this is your total surface area of all the six faces. So this formula you have to remember while solving the questions for related to cuboid. Now what is the lateral surface area? Again you open like in this fashion only, and you remove the top and bottom part. It is in the side walls, the faces excluding the top and bottom. Okay, not this, not this, makes the lateral surface area of cuboid. So area of this plus this plus this plus this. So 2 times this and this will be same, and this and this will be same. So 2 times h into l plus b into h. And if we take the common, 2 is outside, we can take the common h, is 2h. Lateral surface area is 2h l plus b. So for lateral surface area, understand this concept very clearly, that roof and bottom are not considered while calculating the lateral surface area of cuboid or for any figure. So this you have to remember, 2 into h l plus b. Now similarly, this is the cube. One property of cube is that all the sides are equal. So in this all the sides are L. So for total surface area, this is a square L L L L. So L square plus L square. This will say L square L square L square L square. Now total surface area will be 1 2 3 4 5 6 6 L square. Let's say that a total surface area of cube is 6 L square. And lateral surface area, again remove this part, remove this part, 1 2 3 4 4 L square. This is very simple. Lateral surface area of cube is 4 times L square or 4 times side square. So don't confuse A square or B square or C square. It is not, is it 4 times side square. I mentioned here L, so it is L square. Sometimes it is mentioned A, so it is A square. So just mention 4 times into side square, or total surface is 16 times into side square. L is equals to side. Now for cylinder, so this is how a cylinder looks. If you make a roll of paper and make a cylinder and you open this, so this is the upper circle, this is the lower circle, and you know the perimeter, this is the radius and this is the height. So you know the perimeter of circle, this is called the perimeter of circle. Okay, so if you cut from here and open this, it forms like this only. This is the upper part, this is the lower part, and this is the length. This length is nothing but perimeter of this part. So perimeter of circle is 2 pi r, and this is the height given. So to calculate the total surface area, you calculate the area of this circle, area of this rectangle, which is length into width, and area of this circle. So what we will get? Total surface area we get pi r square plus 2 pi r h plus pi r square. 2 pi r square plus 2 pi r h. You take the common 2 pi r from both this. So it will be r plus h. So total surface area of cylinder is 2 pi r plus h. Okay, this you have to remember, total surface of cylinder 2 pi r into r plus h. Now again lateral surface area. So what I have given told earlier, remove the top and bottom. In lateral surface you have to calculate the area of this part only. So what is this? 2 pi r h. So lateral surface of cylinder is 2 pi r h. Now we'll be solving the questions one by one, and we'll learn more about the formulas while solving the questions. Okay, now first question, there are two cuboidal boxes as shown in the adjoining figure. Which box requires the lesser amount of material to make? So to making a cuboid box, you have to make all the six faces, this face, this face, this face, this face, back and this side. If you make like this side. Now see what is given in this figure. This length is 60, this width is 40, and this is 50. So clearly it is a cuboid. And in this figure, this is 50, this is 50, this is 50. Means length, width, height all are same. So this is a cube. Cube is also a cuboid with the same dimensions, same sides have equal dimensions. To determine which box, since we have to calculate the area of all the 6 faces, so we have to calculate total surface area. Okay, to determine which box requires the lesser amount of material, we need to calculate the total surface area of the box. Once you get this, what we have to calculate, half your problem is solved. Now you have only to learn the formula of total surface area of cuboid, which is very important, easy and very important for both this. Now total surface area of figure 1. Figure 1 is say cuboid. 2 LB plus BH plus LH. When you solve this, 6400, 6 into 40, 6 4 24, 00, 5 4 20, 00, 6 4 30, 00. Add this, you will come up with this. Now total surface area of figure 2. Figure 2 is your cube. Length given 50, width 50, height 40. So it is a cube. So total surface area of cube is 6 into side square. L square is side square. 6 into 50 square. 6 into 2500. So 15,000. So clearly you can see this is 15,000 and that is 14,800. So box 1 requires less material, or you can say cuboid require less material. Or you better write box 1, because in question it is given mentioned cuboid only, it is not mentioned cube. If you use the formula of cuboid in this also, you will get the same answer, 2 into LB plus BH plus LH. Now next question. A suitcase with measures 80 centimeter into 48 centimeter into 24. This is length, width, height. Is to be covered with a tarpaulin cloth. Okay. So this is also a cuboid. Okay. So this is 48 given. This is 10. Sorry, this is 80. This is 48 and height is 24. How much meters of tarpaulin of width 96 centimeter is required to cover 100 such suitcases? So width of tarpaulin is given 96. You have to calculate how many meters of in how many meters. Okay. So what all the dimensions are in centimeters. So what your answer will come is in centimeter. So you have to convert the centimeter into meter. And how many meters of tarpaulin means you have to calculate length, because width is already given to cover 100 such suitcases. Okay. So you have to calculate the area of one suitcase. How much tarpaulin will be required to cover one suitcase? So length, width, height. So this is a cuboid. So total surface area of cuboid, 2 into length into breadth, breadth into height, length into height. So when you solve this, it will be 2 into 18 into 48, 48 into 24, 18 into 24. This, you have to multiply this separately. So it will come out to be total surface area of one suitcase will be this. Now you have to cover 100 number of such suitcases. So surface area of 100 will be multiplied by 100. Now you got the area. Okay. Total surface area, or this is the area of tarpaulin required. Okay. So tarpaulin is length into breadth. Okay. You need to find the length of the tarpaulin. So width of tarpaulin is given 96. Area of cloth you have found it earlier of 100. So length into width. Length will be total area by width. 1382,400 by 96 is the width. So 14,400 centimeter is the length of tarpaulin. Now you have to convert it into meter divided by 100. So 144 meters of length is required. So I hope you understand. You have to calculate. First you have to calculate the area of one suitcase, because this is the total surface area, and to cover with tarpaulin you will require the total. So you have to cover whole the tarpaulin, whole the suitcase, not the certain part or the side part. So whatever will be the total surface area of tarpaulin will be the total surface area of that tarpaulin. So tarpaulin comes length into width, and width is given and area you calculated. So you can easily calculate the length. Now question third. Find the side of a cube whose surface area is 600. So this is very simple. Surface area of cube is 6l square, 6 into side square. You have to calculate side, means you have to calculate L. So this will be go down. L square is 600 by 6. It will come up to be 100. Length is root times 100, 10 centimeter. Not need to explain much. Now, rooks are painted the outside of the cabinet of measure 1 meter into 2 meter into 1.5 meters. This is 1 meter. This is mentioned in your book only. This is 2 meter and this is 1.5 meter. How much surface area did she cover if she painted all except the bottom of the cabinet? So how much surface area did she cover? How much? She covered this, she covered this, she covered this, she covered the back, she covered this side, but she didn't cover the base. Base will be just like your top only. This is a rectangle, so base will also be a rectangle. So you have to calculate the total surface area of this, and you have to subtract the area of base or area that rectangle. So again, this is a cuboid. Dimensions of cuboid: length, breadth, height is given. So total surface area of cuboid is, just apply the formula, this one, it will come 13 meter square. And now subtract the area of bottom. So area of bottom is, this will be only, this is the length and this is the width. So 1 into 2. 2 meter square will be the area of bottom. Now subtract the area painted is total area. This is the total area minus bottom area. So 11 meter square is the area she painted. She has not painted the base. I think you got this. Now next question number 5. Now see what is saying. Daniel is painting the walls and read the question very carefully. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height given. Now there is one catch in this question. Is painting the walls and ceiling of a cuboidal hall. So how your cuboidal hall looks like? Again, make a cuboid. This is how I learn. So painting the walls means this wall, this wall, this wall, this wall, and ceiling, this part. But you shall not mention the floor. So Daniel is not painting the floor. He's just painting these walls and ceiling. Okay. From each paint, 100 meter of area is painted. One can. Okay. So how many can is required? Now you got the catch. So dimensions of the hall, length, breadth and height are given. So you have to calculate total surface area and subtract this. Or other thing is you calculate the lateral surface area. What I have told earlier in lateral surface area is area of four walls excluding top and bottom. So you calculate first the lateral surface area. In that your four walls will be covered and then add the area of this ceiling. This is length and width, length and breadth. So Daniel paint wall and ceiling, not floor. So this is important. If you calculate, your answer will come with floor. So area of four walls is lateral surface area of cuboid. And what is the area of lateral surface area? Formula 2 into h, length plus breadth. Now put the formula. This is the area of four walls, 350. Now calculate the area of ceiling. Area of ceiling is rectangle, length into breadth, 15 into 10, 150. Total area is 350 plus 150, 500 meters square. Now 100 meters square can be painted in one can. So 500 meters square will be painted in 5 cans. So what is the important in this question? To understand what is given, like area of floor not to be taken in painting. So that's why read the question very carefully. If you read the questions, you can read the questions carefully, you can, if you can write the given parameters, and if you can learn the formula, then your problem will be solved very easily. Now question number 6. Describe how the two figures at the right are alike and how they are different. Which box has larger lateral surface area? Means you have to calculate lateral surface area of the cylinder and this cube. Means you have to exclude this part, and from this part and this part. Now how both are alike? Both have same height. We can see height of cylinder is same 7, height of cube is 7 centimeter. Both have base measurement 7. You can see base is 7, here also base is 7, and both are three-dimensional solid. So if it is 7, then its radius will be 3.5. Now how they are different? The cylinder has a circular base and one curved lateral surface. So this is the circular base and this is the curved lateral surface. It is not a straight line. This is something like curved. You might have seen cylinder in your homes also. So that is the cylinder. The cube has a square base and 4 flat lateral surface. So this is the square base and 4 flat lateral surfaces. Now compare the lateral surface area. Okay, so lateral surface area of cylinder is, I have written earlier, 2 pi r h. You don't have to cover the top and bottom. So diameter is 7 given, radius will be 3.5, height 7 given, lateral surface area is 2 pi r h. Can you calculate lateral surface area of a cylinder? Similarly, lateral surface area of cube, it is very simple, 4 into side square. 4 into 7 square is 49, 196. So 196 is greater than 154. So the cube has larger lateral surface area. I hope you have got this. Now next question number 7. A closed cylindrical tank. Okay, closed cylindrical tank of radius 7. Now just draw one cylinder here. So this is a closed cylinder tank of radius 7. So this is 7 meter and Height 3 meter is made from sheet of metal. Okay, this is made from sheet of metal, like one in your house cylinder, that gas cylinder. How much sheet of metal is required? Means you have to calculate the area, but which area, total or lateral? This you have to understand, because it is written closed surface, means it has this part also and this part also. In hollow cylinder it will not be top and bottom, since it is closed. So this plus this plus this, so you have to calculate total surface area. Given radius 7, height 3. Since the tank is closed, it had curved surface. This is the curved surface, and top circular base and bottom circular base. So we need to find the total surface area, and unit the total surface area of cylinder is 2 pi r h plus r. 2 pi r h plus 2 pi r. Once you get into this, up once you reach up to this part, only thing is you have to put the values. Nothing is, and be patient while solving. So 440, this is the area of sheet metal required to make this 440 meter square. Okay, now question number 8. The lateral surface area of a hollow cylinder, lateral surface area given, hollow cylinder given, okay, is 4224 centimeter square. It is cut along its height, so it will be cut along its height this way and formed a rectangular sheet, so of width 33. If you cut a cylinder, make a cylinder of paper and cut and open this, it will be open like a rectangle only, and width of rectangle is given is 33 centimeter. Find the perimeter. You have to find the perimeter, so you have to find the length and then put the formula 2 into length plus 1. Now how to find the length? So area, lateral surface area is given. Lateral surface area is what? Excluding this part and this part, so it will be only the curved part. So if you open this curved path, it will be a rectangle like this. It will open like this only, this. So area of this curved part will be area of this rectangle. This is only the curved part when it was in cylinder. So area of curved part is equal to area of rectangle. Now if you can think up to here, the problem is solved. Area of rectangle is length into breadth, area given, width given, you have to find the length. Just solve it carefully. Length is 128, perimeter is nothing, 2 times length plus width will be 322. Just remember the formula, just and read the questions very carefully. Just a second. Now next question number 9. I think this is the second last question. This is important question. A road roller takes 750 complete revolutions to move once over to level a road. Okay, road roller like cylinder with side view. It will roll this, and how many times? 750 times it has rolled. Just a second, let me take the charger of laptop. Yeah, sorry. So it takes 750 revolutions. Revolutions means this part will go down and will go up So this is the path covered in one revolution. Find the area of the road if the diameter of the road roller is 84 and length is 1 meter. Okay, so road roller is equal to cylinder. So you have seen while making the road, it looks like a cylinder only. This looks like this. I'm making the front views like, and above this is a vehicle which drives it. Okay, so this looks like a cylinder. Area covered in one revolution is equal to, now area covered in one revolution, if you move only this part, only this part makes the road. So when it moves, it will, in one revolution it will cover some this part. When it comes this here and here, so this is the lateral surface area of cylinder, and when lateral surface area, it makes like a rectangle. Okay, so this side part doesn't contribute in making the road. This flat part of the cylinder, which is the curved part, that moves on the road, so that is the lateral surface. So it will be 2 pi r h. Now given is diameter 84, so radius will be 42. Length given as 1 meter, and number of revolutions is equal to 750. Now area covered in one revolution is 2 pi r h. 2 pi r h. Here h will be your length, that is given 1 meter. So 100 centimeter I have written here. So 2 pi r h. So when calculate this, area covered in one revolution will be 26,400 centimeter square. So in 750 revolutions, how much? Multiplied by 750, you will get this. Now 1 meter is equal, 1 meter square is equals to 10,000 centimeter square. So convert it into meter square, divided the answer by 10,000. So this cut, this. So 1980 meter square will be the area covered in 750 revolutions. So what thing you have to understand is the area covered in one revolution is the lateral. So once you get this part, you can easily come to the solution. Now, last an important question. A company packages its milk powder in cylindrical container whose base has a diameter 14. Base diameter is given 14 and height 20 centimeter. This total height is given 20. Company places a label around the surface of this container, not on the top, not on the bottom, on the surface of container. Okay, if the label is placed 2 centimeter from top and bottom, so this is 2 centimeter from top and this is 2 centimeter from bottom. So in this part, so in which part? In this part. So this part is 20 less 2 to 16 centimeter. What is the area of level? So you have to find what is the area of level, or what is the area of this curved part. Okay, now base is given 14, so radius will be 7, height is 20. Label is placed 2 centimeter from top and bottom, so you have to find the height. You have to find the height. Now area of level covers only the curved part. Okay, it is written company places on the surface of the container. Okay, so this is the only the curved part where label is placed. So you have to not calculate this or base, just calculate the lateral surface area of this part. The lateral surface area of this part will be 2 into 2 pi r h. 2 value of pi is 22/7 into r is given 7 into height you calculated 20 less 2 to 4 16. 44 into 16 760. So 704 centimeter square is the area of this level. So I hope you understood all the questions and solutions. So in mathematics, in mensuration or in any subject, you have to first read the questions, write the given parameters, what are given in the question and what is required. And the main thing is you have to learn the formula or at least know how to derive that formula. But you can't derive the formula examination, you have to write the formula. So learn the formula. So now next we'll be dealing with volume of solids and all the questions of 11.4. So and one thing more, if you have any question doubt in any of the questions from any of the book, just write it on the comment section. I will provide the solution with explanation whatever possible. So till then, thank you, keep studying and have a nice day. Like the video, subscribe the channel. Thank you.